solar cells converting solar energy to useful electrical energy in a road sign with an efficiency of 4%. The solar cell supply used by the engineer has a total surface area of 32 centimeters squared. And we've got to calculate the minimum intensity in watts per meter squared of the sunlight needed to provide the minimum current of 75 milliamps to the road sign when it has a resistance of 6 ohms. Alright, so let's just jump across. Now, to make sure we understand what's going on, we've basically got a set of solar panels, and they're connected, so they're actually powering some form of sign, and that goes around, so the current goes that direction. Now, we're told that this sign needs 75 milliamps, and it's got a resistance of 6 ohms. We're told that these solar panels have an area of 32 centimeters squared, and they've got an efficiency of 4%. So those are our key facts they've given us to work with. Alright, so starting off then, let's figure out what power this sign actually needs to operate. So we're going to use twinkle twinkle little star, power equals I squared R. So I've got 75 times 10 to the minus 3 squared times by 6, which means this sign itself needs electrical power supplied. 75 times 10 to the minus 3. I'm going to square that, and then I've got to times it by 6. It means that I actually need 0.03375 watts to actually electrical energy to make that sign work as intended. Now, okay, so that means coming out of the solar panels, I need 0.03375 watts coming out of those panels. Now, what we know is it's got an efficiency of those panels of 4%. So, what I know then is my efficiency is useful power out divided by total power in. That means my total power in has got to be equal to my useful power out divided by my efficiency, which my useful power out I need is 0.03375. My efficiency is 4%. That means my total power going into my solar panels must be, divide that by 0.04, must be 0.84375 watts. So going on into those solar panels is 0.84375 watts, which then at an efficiency of 4% gives me the 0.03375 watts that is needed to power the sign. Okay, so next bit we've then got is our intensity is power divided by area. Now, a note here that they actually want this in watts per meter squared, and they've given us here 32 centimeters squared. Now, we need to convert that across to meter squared. So 0.01 times by 0.01, so 1 centimeter squared is actually 1 times 10 to the minus 4 meters squared. Therefore, our area is 32 centimeters squared, which is the same as 32 times 10 to the minus 4 meters squared. So I've converted that across to meters squared. So the intensity that I need, which is the power divided by the area, then is going to be 0.08375 divided by the area of my panels, which we've just worked out as 32 times 10 to the minus 4 meters squared. So that's giving me my watts per meter squared. So I've got that divided by 32 times 10 to the minus 4 gives me 263.6719 watts per meter squared as my intensity. Now, if I go back, they gave everything to, that's one significant figure, two significant figures. I need to be careful because they told me that was 4.0, so everything's two significant figures. So my answer then is going to be 260 watts per metre squared to two significant figures. Okay, thank you very much. Hope it makes sense.